So we'll start with question number 5. So we have to find the domain. So for finding the domain, we should keep 1 minus x should be bigger than 0. One minus x should be bigger than 0, and 1 minus x should not be equals to 1. So x should not be equals to 0, x not equals to 0, and x is less than 1. And second critical point, this was the part 1. Second critical point is for root x plus 2. So x plus 2 should be bigger than equals to 0. So x is bigger than equals to minus 2. So what are the intersection point? Intersection point is x belongs to minus 2 to 1 minus 0. So we'll proceed with question number 6. First case, log 3x minus 1 should not be 0. Second, log x minus 2 and this should be bigger than equals to 0. From here we'll get x should not be 2 by 3 and x should be bigger than x should be bigger than 1 by 3. This is what we got. From here we get second one, x should be bigger than 2 and it should be positive. So we will be having log x minus 2 base 2 upon log 3x minus 1 less than equals to 0. So from here we will get, if 1 is negative, so if x minus 2 is less than 1 bigger than 0, then 3x minus 1 should be bigger than 1. And second case is x minus 2 bigger than 1 and 3x minus 1 less than 1 bigger than 0. So from this equation we'll get x bigger than 2 less than 3, and from this we'll get x bigger than 2 by 3. So this is satisfying the equation. From the next process we'll get x bigger than 3 and x 1 by 3, 2 by 3. So this case is not identifying. So this is the one solution. This is the one domain. This is the one domain. So we are telling that x should be bigger than 1 by 2, 1 by 3. X should be bigger than 2. And we are telling that x should be bigger than 2, less than 3. So this is the final domain. X bigger than 2, less than 3 is the answer. Yep. Question number 7. Fn some greatest integer. So we see that whatever is coming inside greatest integer, which is x square x plus 1, we'll get that discriminant is less than 0. So that y will be bigger than 0. So any bigger than 0 will be we can take anything which is bigger than 0. So what we can take only one is that x square plus x plus 1 should not be between 0 to 1, because it will come out to be 0. Greatest integer should not be equal to 0, which means that x square plus x plus 1 should not be between 1 to 0. So this is valid for x belongs to R, yes. And x square plus x plus 1 should not be between 0 to 1. So x square plus x plus 1 bigger than 0 is for all x belongs to R, and x square plus x less than 0. So x belongs to -1 to 0. So it should not be. So x belongs to R minus. This is the domain. Question 8. Cos x minus 1 by 2 should be bigger than equal to 0. So cos x is bigger than equal to 1 by 2. So we know that so cos x 1 by 2. So it should be bigger than equal to. So this is minus pi by 3. This is pi by 3. So x should belongs to 2n pi minus pi by 3, 2n pi plus pi by 3. This is the domain. Part 2. 6 plus 35x minus 6x squared should be bigger than equals to 0. Bigger than, but not equals to 0. So we have 6x squared minus 35x minus 6 less than 0. So x is what? So we will be finding x We will solve some quadratic equation. So we'll get x equals to 35 plus minus root under 35 whole square. This is 1225 plus 144 upon 12. 35 plus minus 1369 upon 12. 1369. 3 3 is 9. 469. So we'll simply write it in this way. X belongs to 35 minus root 1369 upon 12. Solve it, okay, whatever value comes from here. To 35 plus 1369 upon 12. We'll remove this quadratic form. So this is the answer.